When I was first introduced to like I guess, the marvel of light itself is when I was introduced to the morpho butterfly and how this seemingly insignificant insect has evolved over the years to develop these super complicated tiny structures that allow it to produce this brilliant blue color of light that isn't really common in nature. Because if you look at like a leaf or a flower, you're not going to see a blue, you'll probably see a red or a yellow or an orange. There's two main ways that light generates color. So the first is with the use of chemical pigments. So these pigments are taking in light and releasing in certain wavelengths of color and absorbing other wavelengths. But what you more commonly see with pigments are these colors like reds and oranges, but with physical color, like those you see with the morpho butterfly or other butterflies or like beetles, you're able to see these shorter wavelengths of color, like 500 to like 400 nanometers, right? So like greens and blues and maybe violets. You're producing light from just interacting with physical geometries, and like if you change these geometries you can get different colors. If you change how the light is hitting these different structures, you're getting different colors. So like you can manipulate the colors you see and perceive simply by having different shapes and having different propagations of light. When you see these super saturated like bright, like deeper colors in nature, that's because that specific species has evolved to produce those colors. Maybe because they're trying to mate, and like how that works is like who looks the best, and sometimes that means who's bluer than the other. Or it could be to ward off predators, like often red is seen to be like a sign of warning, or blue sign of toxicity, so you might want to ward off certain predators. We as humans can manipulate both processes because we have technology and opposable thumbs, so we can draw from nature to produce both of these phenomena to our advantages.